Hi there, greetings. Welcome to Euclidean geometry lesson. On this lesson, we're going to go through some of the most important concepts on Euclidean geometry. Okay, so the aim of this lesson is to understand and apply the theorems in geometry. Okay, so by the time we enter the lesson, you need to have the skills where you know how to work with parallel lines, alternate, corresponding, and co-interior angles. So we'll also revise angles and we'll do identifications of different triangles. So you need to be able to do that and also be able to differentiate between congruence and similarity. I'm not sure if we'll manage to get to that part, but let's start with the lesson and see how far we can take this. Okay, so most of the things you did them in grade 9. In grade 9, you guys talked about uh, lines and angles. Okay, so this is Euclidean geometry. Right. So on this lesson, let's first start and discuss the lines and angles. So you need to be able to know, let's say, the lines and angles. Right. So I'm going to denote this for angles. Right. So I'm going to talk about the type of an angle, the type of an angle. I'll give you the type of an angle, then I'll give you the size of that angle, then I'll definitely give you an example so that you can know how that angle looks like. So first one that I need us to talk about is what we call an acute angle. So an acute angle, so this angle, so an acute angle, uh, it's between 0 and 90 degrees. Okay, so the acute angle, the angle when it is between, if you find that your angle is between 0 degrees and 90 degrees, just know that that angle is what we call an acute angle. So the example of an acute angle will look like this. Let me give you an example so that you can know how an acute angle looks like. So if I have an angle like this, and they tell me that this angle is 34 degrees. So you can see that 34 degrees is between 0 and 90. Then we're going to call that angle an acute angle. Wow. Okay, so now let's move to the next one and see what we can do on the next one. The other type of angle that you need to understand, the other type of angle that you need to understand is what we call the right angle. I think already you know which one is the right angle. Okay, so the right angle, this one will be between 90. Oh, it's not between, it's just equals to 90. I'm very sorry. It's not between the right angle. If the triangle, it's we have an angle that is equals to 90 degrees. Just know that that is what we call the acute angle. And the example will look like this. If I have a triangle like this and I have an angle there as 90 degrees, and then I'm going to say this is a right angle triangle. Okay, let's work on another angle, the type of an angle that you need to know, which is an obtuse angle. Okay, so this will be an obtuse angle. So the obtuse angle is the one that is between, this one is going to be between 90 and 180. 90 degrees and 180. So if you find that you are given an angle that is greater than 90 and the angle is also less than 180, just know that the type of that angle, we call it an obtuse. Since you are in grade 10, they might ask you the type of an angle. What type of angle is this? Especially if you will be doing maybe investigations, you might expect for them they might ask you to differentiate the type of angles. Okay, and then another one that we need to discuss is what we call a straight angle. Right, a straight angle, it's equals to 180 degrees. So it's an angle on a straight line. So if you have multiple angles on a straight line, when you add them, you should get 180. So an example will look like this. So if I have an angle like this at that setting point, so that angle should be 180. The sum of angles in an right, they should be 180. So there are two. Before that, there's this one that likes to give most learners problems, is what we call the reflex angle. Okay, so I'm going to explain this one. The reflex angle, this one, it will be between 360, between this one will be between 360 degrees and 180. It should be 180 and 360, and the angle will look like this. So it should be less than 360 and greater than 180. So in most cases, you'll have a point like this, and then the angle will look like this. So the angle will move all the way to that. It should not be it should be between 180. So for example, if I give you that angle and I say this angle is 308 degrees, so you can see that 308 is greater than 180, and it's also less than what is this, 360. So the last one that I want us to discuss, it's revolutionary, and then on this one, this will be the last one. Revolution angle. So this one, it should be equal to 360, and I'm not going to waste time on that one because I think you guys know that when we say revolutionary angle, we are referring to angles around a point. So if I have something like this, and the angle around a point should give us 360. Okay, so we're going to take all the information that we have now. I'm going to give you guys the theorems on the lines and angles. Né? So we're going to go and apply this thing to answer some of the exam questions. Right, but let's go through the theorems first. So I want us to talk about the theorems on lines. Okay, so the theorems on lines and angles. So the first one, very important, the first one that you need to understand, if two lines intersect each other, I'm not sure if you guys want me to write the statement, but let me write the statement. If we have two lines and those two lines, they intersect each other, then we're going to say then we're going to have the pairs. So then the pairs of vertical opposite angles, vertical opposite angles will be equal. Okay, so now the most important thing that you need to keep in mind here is that vertical opposite, they are equal. Okay, I'm going to give you one example, then we'll definitely work on that. So let's say I have a line, and I'm going to call this line AB, and then we have another line that goes in that direction, and then I'm going to call this line CD. So we can see that if this point here, if this point, we call this point maybe E, and then we name this angles as E1, E2, E3, and E4. So those are my angles. And let's say that E4 is given as 47 degrees. So this 47 degrees is definitely for this angle, right? It's definitely for this angle. Okay, so now in an exam, they might want you to find E2, E3, and all that other angles, which is what we're going to discuss now. So when you determine angles, you need to have what we call a statement. You also have to give us a reason of your statement, why you are saying that. Okay, so let me look at this. We are saying that vertical opposite angles are equal. Okay, so if we have two lines that are vertical opposite, the if we have two lines that intersect each other, the angles that are opposite, they will be equal. So angle E4, it's equals to what? Angle E2. I hope you understand where is that coming from. So I can say that angle E2, it will be 47 degrees. That is my statement. I need to give a reason. This is how you write a reason. You're going to say your reason is it's vertically opposite. Right. Okay. Now this angle here, okay, I can find E3. I can find E3. Look at this. I know that if I draw an angle like this, you can see that's an angle on a straight line. Remember, we talked about an angle of a straight line. We said that an angle of a straight line is equals to what? An angle of a straight line is equals to 180. So I can use that to find that angle E3. Okay, so I'm going to say that angle E3, when I add that with angle E4, I should get an answer of 180 degrees. What is the reason? Angles on a straight, I just don't want to write this in full, but it's fine. This will be angles on a straight line. It's equals to 180. So we can solve for E3. We know that E4, we have for that as 47. So I'm going to add this and say this is 47 degrees and equate this to 180. Then when I solve, the 47 has to come this side to be negative. Therefore, I can write my angle E3 to be equals to 180 degrees. Then I subtract that 47 degrees. The answer that I get when you subtract the two, that will be your angle E3. So now, when I put this on the calculator, what is angle E3 equals to? Angle E3, it will be 180 minus 47. So 180 minus 40, that's 140 minus 7, that's 133. So this will be 133 degrees. So that is angle E3. Okay, so if angle E3 is 133 degrees, what is angle E1? So these two angles are vertical opposite angles. Therefore, we can say that angle E1 is equals to angle E3, and the reason it will be vertical opposite angles are equal, okay? Vertical opposite. So this is how you use the first theorem. This is the first theorem that you need to understand. If two lines intersect each other, then the pairs of vertical opposite angles are equal. Let's move to the next theorem. Okay, so on the next theorem, this will be theorem 2. The second theorem is that the sum of angles, okay, so the sum of angles on a straight line, which is something that we already did, but I just want us to do more examples. The sum of angles on a straight line, they must end up to 180 degrees, and I'll definitely give you an example that we can look at. Okay, so if I have a line like this, and I have this point that has multiples angles. The first angle, let's say this is 29 degrees. I have another angle there which is x. Then I have another angle which is 49. Then the last one is 46. So we can find x. We can find x, and then we can definitely do what? We can definitely find x. So, and we need to have a statement and what we call a reason. Okay, so your statement is that the angles around a straight line, if we add all those angles, they should give us what? They should give us 180. So I'm going to add all those angles. I'm going to say this will be x plus 46 plus 49 plus 29, and this will give me 180 degrees. And the reason it's angles on a straight line. That's my reason. So now look at this. The 46, the 49, the 29, those are like terms. You need to add all those numbers. You need to add the 46, add it with 49, add it with 29. So this will give us x plus, we get that to be 124 degrees. Then this is still equals to 180. What is the aim? To solve for x. So you need to take this 124, move it to the other side so that it can change from positive to negative. Therefore, this gives us x to be 180 degrees, you minus 124 degrees. The answer that you get is your x, which is 56 degrees. So x is 56 degrees. So when they ask you to find x, you write your statement down, then you give them a reason why you are saying so. Right. Okay. I hope you're still with me on that. Right. We have some of the things that we can discuss, which is two angles that end up to 90 degrees. Let's say you have two angles that end up to 90 degrees. What do we call those angles? So we're going to call those angles complementary angles, okay? So when they say complementary angles, complementary angles, these are two angles that when you add them, you get 90. They add up to 90 degrees. That's the first one. The second one is supplementary angle. Okay, so now you also need to understand how to use this with supplementary angles. So this one, you add, these are two angles that it can be two or more, it can be two or more that add up to 180 degrees, which is what we just did on the previous example. So when you have two angles and they add up to 180, just know that those angles, we call them supplementary angles. Okay, and then the last one, we have lines that intersect at the right angles. So if I say this is perpendicular, 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 okay, perpendicular. So if I say perpendicular, meaning perpendicular. So perpendicular, this has to do with what? This has to do with right angles, which is 90 degrees. Okay, so and then the last one, remember we did theorem 2. Let's go and work on theorem number 3. So on this theorem number 3, it has to do with the sum. So this will be the sum of angles around a point. Okay, so when you add them, they should give us 360, and we can definitely do an example on that one. We can definitely work on that one. Okay, so let me just give you the drawing, and then let's find the angles. Let's say I have a drawing like this, and this is x. From this, maybe I have another one going that side. This is 130 degrees. And then this is 52, not 25. Let's just put 52 degrees. Then you have this as 360 degrees. Okay, Not 360, man, because when we add this, let's say this is 36 degrees, not 36 degrees. So we can find the x in the diagram. The question can say find, they can ask you to find x in the diagram. Right. So if they ask you to find x in the diagram, you know what you need to do. Give them a statement and a reason for your statement. So now my statement is that when I add all those angles, if I say x plus 52 degrees plus 36 degrees plus 130, and then okay, how many are there? 4 angles. Then we need to get 360 degrees, and the reason it will be angles around a point. That will be my reason. Angles around a point. So from this, I can definitely, or you can say a revolution. So I need to add all this angle. 52, I need to add that with 36 and 130. This gives me x plus, when you add all these three numbers, we get 218 degrees. Then I need you to solve for x. Move the 218 to the other side. X will be 360. You minus 218. Then you punch that on the calculator and get what is x equals to. Okay, so x, when we put this on the calculator, it's 142 degrees. And that's it for this one. Okay, so now we're going to go through the most important thing. But before we do that, I need to give you something to work on, and I need to see your comments on the section and see if you guys understand the concept. I need you to pause the lesson, work on this, and put your comments there, and let's see if you understand this. But if most of the learners get it right, we don't have to do a video explaining this question. I need you to determine with reasons. Okay, the value of each letter, the value of the letters. Right. So the first one, let's say you have two lines like this, and then this angle is x plus 20 degrees, and then this angle is 3x minus 40 degrees. Find x. The second one that you can work on, let's say we have a straight line like this, and then a line that is perpendicular, and then this line that is perpendicular, let's say that is divided in this way. Let's say, because remember, exam won't be easy now. Let me just give you that complicated question. Let's say this angle is 43 degrees, and this angle here is x, and then this angle from this point all the way to that point, yeah, this one is going to be very tricky, and that will be y. I need you to find y. I need you to find y and x, and then this side I need you to find x. Then you're gonna say number one, x is equals to, on your comment, on the comment section. Then you're gonna say number two, x is equals to y is equals to. Let's see how many learners will be able to find this right. Okay, just don't put the methods, just only the answer. Okay, right, and that's it for this one. Then we're going to do the most important thing when we do the next lesson. So on the next lesson, we're going to continue with this one, where we will be talking about when you are given two lines that are parallel, which is one of the most important things, when you have two lines that are parallel. Thank you very much for watching. I'll definitely upload the part 2 of this lesson, when we'll be dealing with parallel lines.